Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will talk about hypothesis testing when sigma, the population standard deviation, is not given. So last time we talked about z-test, so the hypothesis testing on a mean when we know the population standard deviation. Now, unfortunately, in real life, this is very unlikely to happen. Most of the times, we do not know the population standard deviation. So in that case, we will be using t-test, okay? We will be using student t-distribution as the base function to determine the conclusion of each of the problem, okay? So just like with confidence intervals, when sigma was given, we used z-intervals. When sigma was not given, we used t-intervals. The same exactly idea is going to happen here. So let's take a look at a problem on your homework, and I chose problem 10. So this is section 9.3. Problem 10, you will have very similar numbers, probably the same setup, okay? So let's see what we have here. Let's say the average size of a new house built in a certain county was 2,271 square feet. Okay, then we got a random sample of 20 new homes built in 2010, and we got a sample mean of 2188 with a sample standard deviation of 222 square feet. So this is the information that's given to us, and we want to answer all of these questions. Using alpha 0.01, does this sample provide enough evidence to conclude that the average house size of a new home in this county has changed? Okay, what we're going to do, we're going to go to our Excel file and we're going to go to one mean t-test. That's the tab. And let's make sense out of this problem first. So the null hypothesis will say that the mean is 2271. So right now I'm just going to say mu is 2271 here. And the alternative hypothesis, let's see, what is the question? Has this changed since 2016, right? Has this value changed? So that's not equal to 2271. Okay? So let's see which option would be the correct option for part A. That looks like this one. Okay, let's check, that's correct. Okay, the next question is determine the critical value, which means we need to compute our t-statistic. So alpha level is chosen, null hypothesis is 2271. Sample mean 2188. That looks different from 2271. The question is it different enough? Sample standard deviation is 227. Okay, and what is the sample size? 20. All right, okay, so we have all numbers computed for us. Over here to the right, you have the critical values. Now, this is a two-tailed test. That means this is our critical value, plus or minus this one, right? And on this side right here, we have p-values and the t-statistic, okay? Oh, this should say t-value. All right. It's not essential, but let's fix that anyway. Okay, so let's see what the next part is asking. Determine the critical values. So the critical values are rounded to 3 decimal places. Since this is a two-tailed test, there's going to be two of them. Negative 2.86 and positive 2.86. Why did it not like that? 3 decimal places. Okay, so we gotta add 1 here and 1 here. All right, these are our critical values that split the distribution into critical and non-critical region, right? So the test statistic That is the value that's computed over here. Negative 1.635. They want 2 decimal places. Negative 1.635, so that would be 0.64. Okay. Now the question is, what do we do with this? Okay. Negative 1.64 falls between these two values, right? It's not exactly in the middle, but it's less than 2.861, but it's greater than this one right here. Okay, so it falls into non-critical region, which means we should not be rejecting the null hypothesis. So the question is, which part is correct? When we do not reject the null hypothesis, we don't have sufficient evidence to support the alternative. So we're going to go with option B. Do not reject the null hypothesis. The data do not provide sufficient evidence to conclude that the average house size has changed since 2006. In simple language, this means that 2188 square feet is not different enough from 2271. Okay, let's check the answer. That looks correct. Okay, the p-value, you already know approximately what should that be. That should be greater than 0.01 because we did not reject the null hypothesis, right? So let's go back to our file here, and this is p-value for two-tail test, so 0.1185. They want 3 decimal places. Okay, 0.118. 0.118. That is a large p-value. It is bigger than alpha level. We still would not reject. So again, here's an example of 2 methods. Critical value method. Here you compute your critical values, and then you find the t statistic and see if this number falls outside of the range for non-critical region. Okay? It doesn't. It falls into the non-critical region for our case, which means we do not reject the null hypothesis. P-value, you compare this value to your alpha level, way bigger, right? 0.118, a lot bigger than 0.01. We do not reject the null hypothesis. Okay, so this is how you would do your hypothesis testing with t-test when sigma, the population standard deviation, is unknown. All right, thank you for watching.